for that introduction, Vicky. So I'm just gonna do the introduction and then hopefully a live demo. And you're always a little nervous when that happens, but everything should be fine. And then Sébastien will go further into advanced functionalities of the tool that we are presenting today, which is called archeoViz, as well as what we call the archeoViz portal. Sébastien will explain more about that later. But basically, it's a tool for visualizing archaeological data, specifically spatial data. So I'm going to talk a little bit more about how important that is in the realm of archaeology. So a little bit of a context about data sharing and the absence thereof in archaeology. Oops, no, I can't. Okay. So first of all, we're not really going to talk about all the kinds of data in archaeology that there is, but specifically spatial data. And for archaeologists, spatial data is 3D data, which differentiates our data from data that can be like spatial data that is used in other disciplines such as geography. So for us, the third dimension is very important because it relates to stratigraphy. So really, we're talking about 3D and not just 2D. And so recording spatial data in the field on archaeological sites has always been a point of an important point for archaeologists. But there's a paradox between the tremendous effort that is and has been invested into that into recording that data, and then the actual use that is being made of that same data. So actually, when you look at the history of the discipline, recording artifact position in the site in 3 dimension has always been a point of interest, basically since the beginning of archaeology as a discipline in the 19th century. And there was a turning point, I would say, in the middle of the 20th century when in the 1950s and 1960s, where archaeologists started to systematically record spatial coordinates in the field. And then since then, of course, there have been changes in the tools that we use to do that, specifically now and since, well, the late 80s, but really has been generalized a lot more recently, at least in my experience. A lot of sites still don't use that technology, but now more and more sites use total stations to record those spatial coordinates. But regardless of the technology, the idea has been around for a really long time that we need to record the artifact position as accurately as possible on sites. This is annoying, sorry. And so just a couple images to illustrate that point. But what is kind of paradoxical is that that data that we spend so much time and effort recording is actually not used very much. It's actually way underused. Basically, that data is usually just used to create some figures, so mostly maps, of course, so basic cartography, and also like we do often like vertical projections of artifacts to look at the stratigraphy. Sometimes a little bit of statistics, but honestly, it's kind of rare. So we have like large amounts of very specific data that are basically not being used, or at least not as much as we could use them. And also there has been a lot of loss of data. This typically happens because archaeologists usually want to keep that data, and so they keep it, well, they used to keep it on paper, still happens today, of course, but now it's sometimes they're on like hard drives, and then the archaeologist dies for example, and then their spouse puts everything in the trash, and then we lose a whole like years of work because of that. And so still nowadays, but it has been a long time issue, data sharing, and specifically data sharing of those artifact position, so spatial data in that small scale of the site, is not widely shared at all. So of course the let's say the digital revolution, so the advances in digital technologies should have changed a lot of the situation, but really, I I guess it didn't. I mean, it changed a little bit, but not as quickly and or as widely as we could have expected. There are some spatial data sets that have been shared on data repositories, both in some repositories that are specific to archaeology, such as TEDAR, which you may be familiar with, and also in like more generic data repositories such as Zenodo or GitHub. But really, when it comes to spatial data, most of these data sets are not at the site scale, but more like sites within an area. And consequently, they don't really care about the third dimension because that's only really relevant when you look at one site, but not really if you look at a whole area. Second of all, in the papers that are being published, even in papers that are focusing on spatial analysis, the actual spatial data is very rarely published. And the publications sometimes include the code, but not the actual data, unless the journals actually have that as a requirement, which is not very often. So, of course, archeoViz is not the first attempt at a solution to bridge that gap. There have been other solutions that still exist or that have existed, and they fall under three categories. So, there have been software that I would say like that is very tailored to archaeological spatial data and its visualization. But usually these are programs that were made for specific data sets or specific types of sites or specific statistical methods. And so they're not really easy to generalize to a whole bunch of time periods or problematics that we can have in archaeology. And then, of course, there is GIS, which is huge in archaeology. But of course, these are complex software, which means that a lot of archaeologists are actually not able to use GIS software. And also, the issue with GIS is that, again, it is focused on 2D and I guess 2.5D, but it's not really made for 3D data. I mean, of course, archaeologists have been hacking that for essentially since GIS have been used in archaeology, but it's not really the main focus of GIS software, which is made for 2D data. And then there are also tools that are both spatial data repositories and visualization tools. Specifically, we have two in France that are archeoViz and archeopen, and there are also other similar tools that exist. But again, the focus is on the larger scale, not on the side scale. And so there is also no third dimension usually. These are just essentially maps of sites, right? Which is also, which is, of course, very useful, but not really a solution for all that very precise spatial data that archaeologists actually record in the field. So essentially, the data sharing in archaeology, especially when it comes to that very specific data, is still a problem, essentially, and it has been for a long time, and it's still not fixed. Here is a drawing or a figure, I guess, from a book from 1968 where essentially the idea was right now all of our data is in different silos, but in the future we'll have it like a giant database and everybody will share their data together. Well, you know, that hasn't come true. And then still in 2023, same idea. People think that in the future, because of some piece of technology, in this case, the semantic web, people will finally all share their data together and it'll be great. But this hasn't happened really. So same problems, which is the data is isolated, and same idea for solutions that never really comes, which is the next technology is going to fix everything, and it really, in the past, it didn't anyway. So these are the main barriers to data sharing and data availability in archaeology, but I guess most of these are also applicable for other disciplines. So these are the reasons that you hear when you ask an archaeologist why he doesn't share that type of data. First of all, there are no tools that are easy enough for most archaeologists to master. And there is not enough training in data management. And so these are three arguments that we hear all the time that are kind of linked to each other. And also preparing data for publication takes time, and essentially researchers do not have that time. And then there's the issue of recognition. So archaeologists usually would say, and they're kind of right. Well, why would I publish my data? Because it's not going to advance my career. It's not going to get me a job. What's going to get me a job is to publish papers, not data. So that's a whole other matter. And then finally, there's the issue of control. Yes, if you share your data, you do not usually, or at least you think you are going to lose control over it. And that's a major issue. I think this one is maybe a little specific to archaeologists. I don't know. But usually people who have spent so much time and effort recording that data, they kind of want to control it, and they're not, a lot of them are kind of, they don't really want to share it because they think that it's, it's going to be out of their control. Okay, so I'm going to do a little, I'm going to stop the sharing for a minute so I can give you a demo of archeoViz, and then Sébastien will explain a little bit more of how this tool specifically tries to bridge the gap in different ways than other tools that I just presented. Can you see my browser now?
Yes.
Okay. So Sébastien will talk about it in more detail. But archeoViz actually comes in two parts. There is the actual tool, the visualization tool, and then there's what we call the portal, which is essentially a website where different instances are presented. So that means that you can browse it and see I'm going to explain a little more. You can't actually see the data sets, but you can see you can see the visualization of the data set. Yeah. And so we are right now on the portal. There are over 70 data sets, but you can still, by the way, use archeoViz without being on that portal. So it answers a little bit that question of control, which is you can still be fully in control and use archeoViz. That's one of the points that Sébastien will talk about a little bit later. So this is the archeoViz portal. It's multilingual, by the way. And here is a little introduction. And here we have like a map view of all the data sets that are available on it. And then there's like a whole table presentation as well with like some metadata about each site or each database. So I'm going to pick one that is a good example. Oops. There you go. Rivo Bombrini in Italy, which is in English because some of them are in French. So I picked one. I had to pick one in English. So basically what actually happens is when an archaeologist wants to create an instance of archeoViz on the portal, they get in contact with the team, which is three people, and then we exchange and we build the actual instance as well as the little text that you see here and all the metadata just to present the instance and the site, as well as bibliographic references as well. So this is the most interesting part, which is a 3D plot of the artifact positions. So you can't, as I alluded to earlier, you can't actually get access to the data set through that portal, because that is not the point of archeoViz. The point of archeoViz is just to visualize data that may be hosted on your computer or on the server or on a repository. But archeoViz allows you to promote that data set, essentially. And so that is why on the bottom, can you see my mouse, by the way?
Yes.
Yes, okay, good. At the bottom of my screen there is a table that is empty because you can't get access to the whole data table or download it from the archeoViz portal. However, if I click on a point here, then I will get the row that corresponds to that point. So the whole application and the whole tool is actually just run like the whole. Let me start again. So the whole app works just with a CSV file. So essentially, you just have to format your data into a CSV file with a specific format, and that's what we can see underneath, like the plot here. So there's some mandatory columns and some that are optional. So for example, here we have X, Y, and Z coordinates, which of course are mandatory because otherwise you can't see anything. There's also an ID for every object, a layer. Here I can't see because the zoom thing is there, but there are here on the plot, the points are colored by layer, which is the default behavior. And then you can also have a whole bunch of other, there's object type, which is also a mandatory one, but then this one actually doesn't have a lot of extra information. But then if you want to make more columns available, you can. It's essentially endless. You can add as many columns as you want. And then in terms of like 3D visualization, so by default, the data is colored by layer, but you can choose to color it by any variable that you chose to add to your table. I'm going to choose object type in this case, so which is the default one. And in this case, since there isn't a lot of columns in my data, I only have that option available. And then underneath here are all the existing values for that object type column. So let's say I don't want all the values visible. I'm going to choose, say, I only want to see bones, charcoals, and lithics. Uncheck that. And then if I hit refresh, normally, there we go. So now I don't have all the artifacts visible, and now they are colored by object type, right? If I click on there, you can see I should only get lithics and charcoals and bones. So there's also other like visualization options over here on the right. And then I'm not gonna try to do the convex hulls because I'm kind of scared that it will take a while. I don't know, because this is more of an advanced feature. But anyways, so essentially with a CSV file, which is pretty easy to do, that's the whole idea, you can get a quick 3D visualization that you can share. You can also do just 2D maps as well as, sorry, I'm fighting with the Zoom window thingy. Okay, you can also do sections. So, I'm having issues with my window, sorry. So yeah, you can do sections by either in the x-axis or in the y-axis. So if I narrow it down a bit here, I now have less objects, and I can still, I don't have the table, but I do have like the idea of the objects, if that is interesting. All of that is also exportable. I can download map and it will export to my computer. There's also some statistics here, pretty basic. It's just counts of different object types and different layers. There are some more advanced statistics that maybe Sébastien will touch on later. And there's also, so the idea is also that you can export data from archeoViz and then put it into other tools that are more advanced. So I think Sébastien will talk about that a little bit later too. There's also a timeline function because sometimes there's a year column that you can fill into the data, and then that allows you to see really quickly if I can find a year that actually have data in it. 2005. For example, here I can see that in 2005, these are the areas of the sites that have been excavated based on which artifacts have the column year set as 2005, which sometimes can be useful. So I think Sébastien will explain that again later, but there's a reproducibility tab, which essentially I can copy and paste that code in R, and then it will open this exact same instance with this exact same parameters. So this is the because this is a point and click app, so this is made so that you can still reproduce what you just did with your mouse, even though you didn't use code, right? And that's just to help. And this is very extensive documentation over here, especially explaining how to format the table, depending on exactly what you want, and advanced features that you may want to use. Yeah, I think this is probably okay for the demo, unless I forget anything important, but
So
okay.
thank you, Élisa. I'm coming back to the slides. So the remaining time, I will now you have a general idea of what the archeoViz ecosystem is, namely the archeoViz portal and the archeoViz software. And I'm going to give you more information on the background and how it implements and how open science principle and how it has been designed. I'm coming back to the barriers Élisa mentioned earlier, and basically archeoViz has been designed to answer these points. So here you can see that to answer the lack of accessible and handy tools, it has a minimal and very simplistic interface, which is also multilingual to lower the barrier to the learning curve, let's say. It also has a very simple data structure to make it faster to prepare. And regarding recognition, there is a special attention paid to authorships and to promote the work made by researchers on their datasets. So datasets are citable, and the archeoViz instances themselves are citable. And as Élisa said, because all this is open source and can be used offline on your computer, or you can set up a server on your own if you like. The user have full control on everything. So basically, you can forget us, the team. You can forget the server we use and deploy your own archeoViz portal with your own archeoViz instances and all this. Um, all this initiative is based on three main principles. First one is, and is very important, especially when we speak with archaeologists who are reluctant to publish. archeoViz is not about publishing your data. It's about promoting a dataset which has been published somewhere else. And if they don't want to publish it, it's also possible to use it, as Élisa showed. It can be used without giving access to the full dataset. So this is an incentive to publish, but not a publication platform. First concept is decentralization, and the whole ecosystem has been designed as much decentralized as possible in the sense that all the functions are not concentrated and included in one piece of software or one technological solution, but the idea is more to rely on all the effort made by other people in the community and create bridges between these efforts. And the reason for that is that it's more resilient. If one part of this network is down, or if people do not maintain anymore, it can continue. And because it's decentralized, you need something to create bridges and connection between all the pieces. And that's the purpose of the archeoViz portal, which is a federative aspect of the ecosystem. There are four ways to use archeoViz. On the left, you can use it purely locally in your computer, running a R session and running archeoViz in this session. But you can also use what we call generic archeoViz instances, which are online instances with no dataset in it. So you can, following the dashed black arrow, you can upload your data, do whatever you want through the interface, and when you close your browser, nothing remain online. But that's not the purpose and final goal. Final goal is to foster data publication. So in that case, the storage function is not paid by archeoViz, but by other infrastructure. You can use whatever repository you like, Zenodo, OSF, TDAR, Nakala, or whatever. And we plug an archeoViz instance on this data source. Another way to do it is not, so we distinguish between static and dynamic data storage. If you have your CSV file on Zenodo, for example, it's a static file. But another option is to use a protocol, for example, a web mapping service. And when we prepare the archeoViz instance, this piece of code connects to the web mapping service. So it means that if you update your data on your server, it's automatically visible also in the archeoViz instance. These are only a few examples of use. So, for example, Kamiak use a static file stored on Nakala. BDA use a Postgres SQL connection, extra. This figure summarizes the decentralized design of archeoViz ecosystem. I have no time to comment all of it, but in brief, here, let's say you have a dataset which has been published on Zenodo. We plug an archeoViz instance here on this source. So the data are transmitted from the repository to the archeoViz instance. This archeoViz instance is listed in our catalog, the archeoViz portal, and we also create a HAL record and as a reference to this instance. And automatically, this reference is propagated in this database you're familiar with. And this is a way to promote the work which has been done to promote your datasets through this archeoViz instance. And from this archeoViz instance, the data can be sent to other softwares, Élisa mentioned them, for more advanced statistical exploration. And all the metadata, no, not all, some of the metadata are aligned on standards, that one. So this is basically the idea of how the idea of decentralization is implemented. And once again, idea is to create connection between efforts made by other people in the community and not having all the functionalities in the archeoViz ecosystem. Élisa mentioned this. archeoViz is not, because it's a point-and-click application, not very convenient for satisfying reproducibility criteria and expectation, but still we try to do our best in this direction. So it creates the code Élisa show you, but also you can export your visualization as an HTML file, which is still interactive. So you can, for example, use this file and include it in your website or send it to a colleague or use it as supplementary for your publication. So I'm coming back to this idea of sending the data to third-party application. Today we have 5 connected applications, but maybe more in the future. So from this statistics tab, you just have to click, and the data set is automatically transferred to these 5 applications. So archeofrag is about refitting analysis. Explorer is about running a correspondence analysis, which is dynamic and interactive, and you have plenty of parameters you can set. Amado is for seriation and classification. Chinese heat map lies to make heat maps, basically. And seriograph is also for seriation. So it means once you have your data in archeoViz, which is an archeoViz instance, which is very easy to do. You just have to create your CSV and have the right name for the columns. You have access to all these analyses, which are already quite complex. You can do a lot of things only with this and in a very simple way. So now in 5 minutes, I will say some words about the archeoViz portal. So now you know it looks like this. Because in the archeoViz ecosystem, but not only in this ecosystem, we are dealing with many different digital objects, and describing and naming this object is not always easy. So this is an attempt, and very, very rough. But to give some distinction, but it's important to distinguish the data set, which can be stored somewhere else, Zenodo, Nakala, archeoViz instances, which are software and application, but we also have the programming code, because if a data set has been published, sometimes we have to reprocess and reformat it and maybe enrich it to use it in archeoViz. So in that case, we also publish the R code we wrote to reformat. So the idea behind this is to have a complete transparent workflow. Because sometimes when you reformat a dataset, you make choice, and the choice can have an effect on the derived datasets. and the archeoViz portal is also itself software. And each of these units, editorial unit, has a unique persistent identifier. So what the archeoViz portal is, it's a catalog, as we said, a catalog of existing archeoViz instances. It's an interface to browse this catalog, but it's also a standard to describe these instances. And as I said, a hub to disseminate and propagate the reference to your instance in other documentation systems. We insisted a lot on on the points representing individual material objects because it was the beginning, starting point of archeoViz development. But today we have instances where points represent something else, namely sites. So it means we have instances about a region of the world, can be a continent, for example. So the points represent archaeological sites or dating results. And the reason for that is that one type of data set in archaeology, which is very accessible, is dates data sets. And also there is a specific focus on refitting. And the reason for that is just that we are, in other aspects of our research, very interested in this. And also because refitting is very time consuming and it has been done since decades in archaeology, but the refitting data sets are very rarely shared. So it's also, once again, a way to promote to promote this effort. In the archeoViz portal, because sometimes we are interested to know who is using, are people actually using it? So, and also if an archaeologist is happy to create an instance, he or she can be interested to know if people access this instance. And so that's why we have this quite simple statistic is the number of visits, basically by instance. In the archeoViz portal interface, you can search instances by name, country, altitude. It was the case before, it's no longer the case. And also type of remains, pottery, lithic, etc., and period of time. Well, this is the details, but you can retrieve query time periods at different granularity, let's say. If you query Paleolithic, you will also find Aurignacian, which is a part of Paleolithic. We saw this. All the archeoViz instance we reference in the portal are presented and in the same way with a figure, a text, metadata, and a suggestion for citation. And we distinguish between different roles. Excavator, data creators, and data editor. Data editor is a person who maybe reprocessed the original data set for archeoViz. We also have this incentive to have the data as open as possible and a small openness index based on 5 parameters. I have no time to comment today. This is the metadata we document for each instance. And some of those metadata are aligned on standards you're probably familiar with. I already commented this. Oh yeah. Also, I haven't mentioned that the archeoViz metadata are integrated in the Open Archeo platform, which is a semantic web repository for archaeology. And this is the data model using SciDoc CRM representing the metadata of archeoViz. And here, from the OpenArcheo interface, you can make more advanced query. For example, choosing an area and combine different criteria to retrieve archeoViz instances, more advanced search. I'm running off time, so just to illustrate, because often archaeologists are reluctant to publish because they say, my research is not finished. But that's not a problem because since a long time ago already, we have versioning technologies. So this site, La Grande Rivoire, a Paleolithic site in the Alps, is a very good example. The archaeologist was still excavating, and each year he created a new version of the dataset, and they are all listed in Zenodo. They all have a DOI, and we updated every year the corresponding archeoViz instance. And so all this is available to the community and can be explored using their archeoViz instance. No time for this, but I just want to illustrate this. Here, in this case, the archeoViz instance reference the dataset as a one unit. But on the right here, you can see the arrow refer not to the dataset, the full dataset, but also to the individual record in the dataset. And this is quite interesting and important. It means, for example, here, this Barger Gulch dataset is stored on TDAR, but if you click on a point, you have a URL to the corresponding record in TDAR, and where you can find more information about this point. So you can refer to this individual object and access it through the archeoViz instance. The same for this Paleolithic dataset, Bitsings label. So to summarize all this, archeoViz itself is a tool for visual and statistical exploration of specialized data at all scale of analysis today. Can be the site, can be the world. It draws on open science approach. Everything is open source, etc., and a decentralized approach, paying much attention to community control, basically to the fair and care principles. And there is a strong emphasis on interoperability regarding data and metadata. Of course, it's an ongoing work. We are facing some limits and issues. For the moment, the development of archeoViz is only made by me. I would love having more input and help. But and the maintenance of the archeoViz portal, the situation is better, I would say, because we are three of us, Élisa, myself, and Anaïs Vignol, who is not here today. And we are trying our best to get support from institution but archaeological institution in France are still not very supporting it. Well, there are many perspectives, more data, more use, basically, and you can join how to say, a mailing list here to get informed. And last word about the sustainability of all this, because we use everything is open source, including R, the R language, which is supported by a large community, and everything's published, the code on different platforms. We try our best to create a community around the ecosystem. So please join the mailing list. And I say that we have not that much support from archaeological institutions, but we receive support by Open Science and Digital Humanities, Digital Archaeology Organization, namely the MASA Consortium, which is a consortium about digital approaches to archaeology in France. And last year we received this prize from the Ministry for Scientific Research, the prize about open source research software. And we were very happy to receive the label of the prize regarding community, because all this, at the end of the day, is about giving something to the community. So thank you for your attention, and now we will be happy to answer a question.